Chapter 2, Number 69. During the 2014 Olympic Games, snowboarder Shaun White rose 6.4 meters vertically above the rim of the halfpipe. With what speed did he launch from the rim? So we begin, as always, with a picture. So down here I'm going to say we have whatever track he's on and then a halfpipe. And he starts off with some speed going here. He reaches this, where he leaves the pipe, and then he goes up to some height here. And what we're going to do is we're going to say that this is the base of the time we care about, because while he's on the track, he's not in free fall, and we don't know his acceleration. In fact, we'll find out pretty soon that the acceleration is very complicated as you go around a curve, certainly a lot more complicated than simply free fall. But once he leaves the track, he basically is launched with some initial velocity, which is what we're looking for, and then he goes up some height, and he ends up some distance higher, which I'm going to call h, which we happen to know is 6.4 meters. And we know that during this whole time, he's being accelerated by the Earth downward with a magnitude g. So that's our picture. Implicitly, we didn't really say it here, but we drew it. He is not moving at the end. That's how he gets the highest point. The highest point has to be where he's not moving, because he's neither rising anymore, nor has he begun to fall yet. So he's at rest. Also, you'll notice that I've changed variables here, and you don't have to do this, but based on what's going to happen in chapters 3 and 4, you probably want to do this. We generally will take our axes to be rightward is plus x, and upward is plus y. This has the advantage of looking a lot like things from math class. It also lets us make sure we keep track of the horizontal and vertical directions independently, which will be key in the two-dimensional kinematics chapter. At this point, if you still stay with x, it's fine, but I would recommend, if you can, to start moving towards using y for any vertical motion. Anyway, at this point, the equations don't really care what letters you use, so we still have a vertical motion with a vertical acceleration looks like the one-dimensional case we already look like. So, for instance, we'd be able to say, here, we want a kinematic equation. Notice that we don't have and don't care about the time. We weren't given it in any quick form, and it wasn't something that we used or we asked to use. So we're going to ignore it. And we're going to, instead use the equation that the speed at any time squared is the speed at the initial time squared plus twice times the acceleration times the change in position. And this doesn't have a time in it, and we don't need it. So this is useful. And then we can start looking at some of these, if any of these things are nice and easy. For instance, we can say that we end at rest, and that the acceleration is minus g, and that we started at 0 meters and we ended at h. So the equation kind of cleans up a little bit to be 0 equals v0 squared plus 2 times minus g times the height, which we can easily solve for the initial velocity. So we solve that over, and we get that the initial velocity squared is 2gh, or the initial velocity is square root of 2gh, which with the given numbers that we have is 2 times 9.81 meters per second square. Notice here g is, as always, positive. I have already taken care of the negative sign right here, and so g is going to come in as positive, as is its standard, and then the height was 6.4 meters, and it's all under a square root sign, and then we just throw it into a calculator, and we get 125.568 meters squared per second squared, all square rooted, which is just about 11.2 meters per second. So he had to be launched at 11.2 meters per second. I'm going to flag something for you. This relation between the speed of something and how high it goes, you shouldn't memorize it, but you should learn to recognize it and be happy when it shows up, because it shows up a lot. it's basically what's going to happen when you have something which comes to rest at some point after being launched. And it'll show up in a lot of problems, so it's good to see it. You shouldn't ever force things to fit this form, though. This is not a basic equation. It is a derived equation under certain circumstances.